hole would make you travel faster than the speed of light. The only.
Why?
I don't know, but apparently it does. Because the theory on black holes is that you go from, you have like a piece of cloth.
No, I do not have a piece of cloth.
I will put this exactly where I found it. It's the last one.
What?
Magazine. Okay, so here's the theory on black holes, which is,
It's Martha Stewart, does it?
Open
it's
it.
the very
Jump,
last
open
one
it.
in that show.
Open it. Okay. Here's a spot. Here's a spot.
Yeah. Okay. So the theory is that the way we see the world, we're here on wires pi. I don't even know what that says. We're here and we want to get to that E right there. Okay. See that? We believe the shortest way there is the line, right? Shortest possible distance between two objects is a straight line.
2 points,
Yeah. What the black hole theory is that that's not true. We're moving in a curved line because in reality, black hole is here doing this.
Mm-hmm.
They meet. Unfortunately for us, we have to go like that to get to the other end. That's what it looks. That's what the theory on black holes is that we think we're traveling a straight line. In truth, we're going like that. When there's a black hole, that's like that. That's a wormhole. Which means, in other words, that
I'm glad you didn't take the recipe page.
that means is that you would, but at the same time, for some reason in the theory, it includes you actually traveling that straight line somehow. Somehow you travel that distance, but you just travel it quicker because it's weird. So you're moving faster than the speed of light because the actual time it would get you from here to here is faster than it would for light to get from there to there. That
How would I do that?
go through the black hole. Unfortunately, that would include the spaghetti effect, which would turn you into a massive jello. Anyway, so
How did we get from
Wait,
spaghetti to jello?
whoa.
the spaghetti effect is that you get stretched when you go
Who
through.
says?
Well, a black hole's is the big black part, but the actual cause of the black hole is something about the size of maybe a basketball.
The actual black hole is the size of a basketball.
The actual cause.
Oh, the cause of the black hole is
The-
a basketball.
The center of gravity, because the problem is
A
there's
basketball caused the black hole.
a star imploded on itself.
Okay.
And
the size of New York. That's a
No, that's a neutron star.
Neutron star.
You have to be a bigger star.
Sorry, different
create-
subject. Sorry.
I don't quite understand this because what it's saying, I think, is that there's a massive amount of gravity in a point where there is nothing. That's the problem. There is nothing to satisfy that gravity, and there's nothing even there, I don't know. Anyway, so what happens though is that the center point is tiny. So if you were to stand on top of, say, a basketball, you're 5 times its size, right? Probably 6 times,
Me?
actually. No, it's about a foot tall, isn't it? A basketball?
Yeah.
So,
I don't
say
know.
you're a 6-foot person. I'm not 4 feet. Anyway, so you stand at 5 feet. You stand on top of it.
Okay.
You're 6 times its size. When you stand on top of a mountain, you're 6 times its size. It's a basketball size.
Okay.
It might be a baseball size. I don't remember the size. Anyway, sorry. So if you stand on top of a mountain, you know how the gravitational pull would be less, right?
Not noticeably.
But it would be. If you were in the atmosphere, it would be less.
Mhm.
So it would be noticeably here because imagine if you were 6 times the diameter of the Earth away from the Earth. 6 times the diameter. So you're 6 times that far. You feel almost no pull, right?
6 times the diameter
Of the Earth.
of the Earth, away from the Earth, you would not feel.
Yeah, here's the
Any-
Earth. You'd be like this.
You would be weightless.
Well, that's not true. Gravity.
6 times.
gravity always pulls on you. It'd just be minuscule. I mean, you could be a zillion miles away, you'd still feel gravitation. You wouldn't noticeably feel it, but there would be one.
Okay.
So here's the spaghetti effect. If you're 6 times its size, the pull, if you're standing on top of it, the pull on your feet is 6 times the strength as the pull on your head, right? Because it's 6 times closer.
No.
Yes.
No. Because you're talking about, let's say you have a magnet in the middle of a merry-go-round, and you've got your feet are 6 feet away from the middle of the merry-go-round, and your head is 12 feet away from the middle of the merry-go-round because you're 6 feet tall.
Mhm.
That
The
does
pull on your feet is stronger than the pull on your head.
somewhat, but not as dramatically as you're saying.
Well, no, because in this situation, the ratio of sizes is so much different. In this situation, the gravitational pull is that of the, I think about 3, it has to be 3 times.
You need to think in terms of percentages.
That's the same as ratios.
Yeah.
It's, the gravitational pull is about 3 times the gravitational pull of the sun.
But you're talking about
At least.
about your body being 6 feet long, but you're talking about, millions of miles. So aren't you?
No. A black hole's center is about the size of a basketball with the gravitational pull of about 3 suns. It's weird. The gravitational pull is incredibly dense. I guess. Anyway, so what's happening is that you're a 6 foot tall person. I'm dead serious. The black hole center is about the size of a basketball.
Okay.
You're standing on top of it. It's pulling your leg, or your foot, 6 times stronger because you're 6 times its size.
Okay.
One part of you is, so if you were to put this in another way, you would actually, if you had 3 suns put together.
So you're talking about if you were standing on a black hole.
Yeah.
Okay, I wasn't there.
You get stretched
I got it now.
because your head isn't being pulled on very much, but your legs are being pulled on 6 times as much. I mean, you would be pulled on the head a lot because it's a lot of gravity.
But what about being torn apart? I mean, is that any? I mean, you're not totally.
Every
elastic.
single.
You're not elastic. Perfectly elastic. You're not.
Yeah, you're just gonna turn into a tube, pretty much. You're just gonna get. Because the gravitational pull there is so strong, it's all just gonna.
Why
flop.
did you stop videoing?
I'm not. It's still going.
Oh, okay. You don't look happy. Oh, sorry.
Go to bed if you want to
Why
go
don't
to
you?
bed.
I'm not gonna.
Bed.
Alright, I'm done.
Okay.
Say goodnight.
Good night.
Good night.